Let's go ahead and see a different explanation of why the cotangent derivative is negative cosecant squared. So in the previous video, we used the quotient identity, cotangent is cosine over sine. Well, now let's use the reciprocal identity, cotangent is 1 divided by tangent. So we'll take this 1 over tangent of x and rewrite that as tangent of x to the negative first power. So we do want to be very careful and make the distinction that this negative 1 in the exponent does indicate raising to the negative first power and does not indicate inverses. That's a totally different thing, covered in a different video, totally different function entirely. So this here, negative 1 in the exponent means tangent of x to the negative first power. So we can use the power rule, and we'll need the chain rule to find the derivative. So the derivative of cotangent of x is the derivative of tangent of x to the negative first power. Power rule says bring that negative 1 down, subtract 1 of that exponent, so we end up with negative 1 times tangent of x to the negative second power. And then chain rule says multiply by the derivative of tangent of x. Well, negative 1 times tangent of x to the negative second power means negative 1 over tangent squared of x. And then the derivative of tangent we already know is secant squared, so we end up with that. Now let's go ahead and write negative 1 over tangent squared as negative cotangent squared, because cotangent is 1 over tangent, so 1 over tangent squared is cotangent squared, and we still have our negative sign out here. Secant squared is 1 over cosine squared. Now, cotangent squared is cosine squared over sine squared. So these cosine squareds are actually going to cancel, and we end up with, we still have our negative sign, and what's left after the cancellation is 1 over sine squared of x, along with our negative sign gives us negative 1 over sine squared, which is negative cosecant squared, and that's another way of seeing that the derivative of cotangent of x is negative cosecant squared of x.